surprised when Bill picked up this session because I was like, okay, ClojureScript. I didn't realize that we had such advanced developers in India already, using bleeding edge technology like ClojureScript. So there are a few questions I have for you guys before we get started. First is, how many folks in here know Clojure? Even if you've done a tutorial or two, anybody? No? Okay, so a couple of people. Unfortunately, a prerequisite for this session is actually knowing a little bit of Clojure, okay? But I think even notwithstanding that, even if you don't know Clojure, you probably have seen the syntax of Clojure and what it is, right? It's a list, right? You understand it's a functional programming language, basically, that's built on the VM. And ClojureScript is unique in that it essentially is Clojure, but instead of running on the JVM, it runs in a web browser. That's the target, okay? So what we're going to do is, and this is the introductory level session, right? Because not a lot of people, number one, know Clojure. Like there were two people who said they know a little bit of Clojure. So I think you'll be able to get something out of this, even if you don't know any Clojure, or if you haven't done any Clojure in the past, right? You probably have heard of it. You probably have seen it. You may have read a tutorial on it, right? So that's why we're going to start with just a little bit on Clojure, and then we'll talk about why ClojureScript, right? Because I think, especially for folks who don't use Clojure already, it's important to understand why you would want to use ClojureScript, right? So we use a little bit of Clojure for doing big data analysis at my company, but we're starting to experiment with ClojureScript for a number of reasons. We do a lot of work in JavaScript, and we love JavaScript. JavaScript is the best language ever invented, right? So, but we love JavaScript, but we're always looking for new ways to improve how we build software. And our target is JavaScript at the end of the day, whether it's web or whether it's on mobile using Titanium. We write a lot of JavaScript. 80 or 90% of our code base is actually in JavaScript. The other 10, 20% is Ruby on Rails, a little bit of Groovy, and some miscellaneous things in there, right? And some Clojure as well. All right. So let's talk about Clojure for a couple of minutes. Clojure is a list. It's a functional programming language. It was invented a few years ago, maybe I think 6, 7 years ago, by a very smart guy who looked around and said, how is it that we're building applications today? Right? Whether it's server-side, client-side, doesn't matter. What are the programming methodologies we're using? But more importantly, what is the language and the constructs we're using to build languages today? Okay? And was everybody at Venkat session this morning? Is there anyone who's not who slept in this morning? Anybody? No? Okay. So if you're at Venkat session this morning, he talked about where we're currently at in terms of imperative programming. What we do is imperative programming today. Object-oriented, but imperative programming. What we want to do is we want to explore these new ways. Actually, the functional programming is not new by any means, right? The first list was written in 1950 by John McCarthy, right? So we go way back in terms of how long we've had functional programming. So Clojure is a functional programming language, so a lot of the stuff that you know, and the way you think about how to build a solution in Clojure or any functional language is completely different than how you think about something when you're building in a functional language, right? And I'll talk a little bit more about that if we have some time. And I have some slides from another talk I do on functional JavaScript, which unfortunately I'm not giving here, but I talk about the difference between doing imperative JavaScript and doing functional JavaScript, and it's totally different ballgame, right? All right. So Clojure again is a list that runs on the VM. Because it runs on the JVM, the Clojure platform has good Java interop. Essentially what Clojure does is it takes your Clojure file, your Clojure source code, and it builds class files. Because that's what the JVM is. It doesn't matter if you use Scala or Groovy or Java. It eventually takes all those, it takes the source for all those languages, and a compiler has to convert that to a class file, right? Class file basically gets instrumented as bytecode, and then that's what's run on the JVM. So when we talk about ClojureScript, it's still Clojure the language. It has some, it's slightly different though. We'll talk how it's different in a few minutes compared to standard Clojure. But what ClojureScript does is it targets JavaScript runtimes. So what you have is, you have your Clojure file. In this case, it's called CLJS. And instead of producing a class file, it produces JavaScript. And then that JavaScript runs in a JavaScript runtime like V8 or whatever it may be. It can run on any JavaScript runtime for the most part, right? And one of the things that people need to understand up front about ClojureScript is that it is actually a subset of Clojure that runs on the JVM. So when you look at Clojure code, it may be using all sorts of different things that the underlying JVM supports, but in ClojureScript, it's a much smaller set of things underneath because you're running in JavaScript and you don't have the standard Java class libraries available to you. Okay? Again, the target is JavaScript, and it's not Java or the JVM. And one of the things that ClojureScript does, is that it uses Google Clojure. Actually, this slide is wrong. Let me fix this before I forget. It's very confusing, unfortunately. It uses Google Clojure, which is actually just a JavaScript library from the folks at Google to do various different types of things. Apply optimizations, give it extended sets, and other kinds of data structures. So if you're using, like I was talking to somebody who uses EXT.js, so Google Clojure is not like EXT.js. It's a much lower level library that gives you all sorts of different, it's JavaScript again, right? It's called Google Clojure, which is an unfortunate name because it sounds just like Clojure, right? But essentially, it's a JavaScript library that allows you to do lots of different things. It gives you advanced collection. It allows you to do things like set. It has optimizations built into it. Lots and lots of other things. Okay, but we're not going to talk too much about that. And before we get into some details, I do want to talk about why ClojureScript and why it's important, especially if you're a web developer. This is one of the most exciting things that's currently happening in the space, in my opinion. Right? There's a growing community around ClojureScript. Sorry. So, how many folks in here are JavaScript developers? All right. Hopefully everybody's hand goes up, right? Because if you're here and you're interested in ClojureScript, you're basically you're also a JavaScript developer, or interested in JavaScript. So we know what some of the problems with JavaScript are, right? There's inconsistencies in the language. If you do a double equals, so in the last session of the day, I talked about some of these inconsistencies in JavaScript in the advanced JavaScript for Java developers. There are lots of little nuances in the language which just don't make sense. And if you've read JavaScript, the Good Parts, which is an excellent book, he talks about how to write proper JavaScript. And there are several websites like WTF.js. I'll just show you really quickly. This is a great website. You guys know what WTF means? Right, okay. And of course, I'm not connected to the internet. So, try this. I'll just take a second to see if this works. If it doesn't, I can just show you. Well, actually, let me just show you the code. All right. So let's go look at some of the kind of weird inconsistencies in JavaScript. So we have a basis for why we're interested in Clojure. Okay. So let me go find a couple of good examples. All right. So actually, let's this one. A lot of different examples. So, all right. So this is a good one right here. All right. So if you have an array or an object literal in JavaScript, like what we have here, var c equals x to 1 whatever, right? Or this could be an array. What happens when we run this in JavaScript? If we do c equals d or c triple equals d, what's going to happen? Right? What results should we get? Should we get true or false in this case? Let's have a look at this. Right? You guys are JavaScript developers. So what happens when I run this? Well, what will this console.log print? What will this print? And you know, what results should we get when we run this? Okay, so somebody said the first one will be true and the second one will be also true. Maybe? I don't know. False. Okay. So, but when you run this, unless somebody said false and false, you were wrong. Right? You actually get false for both of them. The reason is in JavaScript, one of the things that you don't get out of the box is you cannot compare objects, right? Because when you have an object literal, it's an object. Let's do an array. So let's take this really quickly, and let's make this into an array. All right? I'm going to do the same thing down here. Comment this out for now. Actually, I could have just uncommented that code. All right. let's make this into an array and run it again. And I actually just ran it again. Let's put a console.log. Okay, let's go run that. And you'll see we still get a false and a false, right? Because in JavaScript, you can't compare objects to each other. You can't compare arrays to each other. Basically, you can only compare primitives. And this is just part of the problem, right? Say we did something like this. Let's go down here. Let me take these console.logs out. Get rid of that. And I'll just comment these out for now, right? What happens if you do console.log 1 equals 1? What happens if you do this kind of comparison, right? You get you get a true, okay? So if we flip this around, we still get a true, but when we try to do comparison on 0, and I'm going to totally mess this up because I'm winging it right now. Right, so that works, and then when you use a triple equals, obviously this isn't going to work because of the way JavaScript thinks of types and the way the double equals and the triple equals are different things. One does identity and the other one does a straight comparison with type coercion, right? But anyways, my point is that JavaScript has some inconsistencies which make it difficult to work with. The other problem, and sometimes this is not necessarily a problem, but it's also JavaScript is a completely open and mutable language. You can go in and change anything at any given point in time whenever you want, which is extremely powerful sometimes, but it's always very dangerous, right? You can do really bad things if you're not careful. And if you've done any JavaScript, you know that doing object orientation in JavaScript is extremely verbose and complex. And there are lots of, and to make things even more confusing, there are lots of different ways of doing things in JavaScript in terms of object orientation. A lot of people do straight prototypical inheritance. The thing that, and if you look at what a lot of framework builders do, is they use parasitic prototypical inheritance. And then you have other languages like Coffeescript, which essentially introduced the class keyword and other things like that to make JavaScript more object-oriented. Okay? And in my opinion, that's the wrong way to go, because JavaScript, even though it supports object orientation, it's just too verbose and it's too complex. It's hard to write a maintainable code base with it, right? And the other problem is that there are not a lot of high-level programming constructs in JavaScript. It just doesn't have some of the constructs that we need, whether it's for doing iteration or for doing mix-ins or anything like that. Some of the higher-level constructs that you need when you're building software. We talked a lot about why JavaScript is bad. Well, what are some of the good things in JavaScript? First of all, JavaScript virtual machines are super fast today. V8 probably rivals the JVM in terms of speed, right? Whether you're looking at synthetic benchmarks or real-world benchmarks, if you write good JavaScript, you can get really great speed out of it, and that's great. And obviously, the other thing is JavaScript is ubiquitous. It's on everybody's desktop right out of the box. And with NodeJS, we also have JavaScript on the server. But probably the best thing about JavaScript is that it is a first-class functional programming language. We focus too much in the JavaScript community historically on the object-oriented nature of JavaScript, right? We try to build these class hierarchies. Because why? How many people in here are Java developers, right? Who's not a Java developer in here? Anybody? Okay, right. So what do you do in the Java world when you're building a solution? You write a person class. And then from that person class, you have supervisor extends person, employee extends person. And then from there, you may have contractor extends employee. And you build this big object graph. And you're like, yes, I feel great. I've modeled the real world, right? But unfortunately, well, that's the way we think. Because we've been doing this for years. We've been writing Java, we've been writing Ruby. We think in an object-oriented way, right? But what I challenge you, and especially after seeing Venkat's keynote this morning, what I challenge you is we need to start shifting to more of a functional paradigm, especially if you want to use something like Clojure. Clojure is a programming language, and so is ClojureScript. So you have to think functionally, right? We don't model the world in terms of a person object and an employee object and an organization object. What we do in the Clojure and ClojureScript world is we just use simple data structures. Actually, two of them. We use arrays and we use hash maps. And you might be thinking, well, how can you model something as complex as a company and an organization and all the different types of people using those two simple data structures. It's actually not that hard. It's actually much simpler, right? It may not necessarily be easier initially, but it's actually much simpler to model the world with using just those two types of data structures. And if I have time, I'll show you what I mean. Right? I have some examples from another slide deck that I can pull up. All right. So again, JavaScript, functional programming language. It has first-class functions, and it supports closures. JavaScript has always supported closures. When did they add closures to Java? Is Java 8? Is anyone using Java 8 right now for real? No. So for practical reasons, even Java doesn't support closures yet. Yeah, you could use Groovy to get closures. You could use Scala, and you can cry yourself to bed every night, right? But that's how many. Is anyone using Scala in here? Any unlucky people? Okay, right. I personally hate. Is this being recorded? I don't remember. But I'm not a big fan of Scala because I think it introduces too much complexity into your programming environment without giving you that much gain. Right? That's my opinion. There are a lot of other people who have the same opinion, and then there are obviously other people who love Scala because they love to build complex things. I like to build simple things. So I'm getting old now. I'm not young like you people in the audience, right? I'm not 25 or 30 years old. I can't have all this complexity in my brain. It drives me insane now, right? So I like to keep things simple. All right. So in terms of other languages that compile to JavaScript, there's actually a bunch of great options. There's Coffeescript, there's TypeScript, Dart, right? There's several great options here. Right? Is anyone using any of these three, Coffeescript, TypeScript, or Dart, to do any JavaScript in here? No? Okay, that's all right. So these are basically languages that conform to the object-oriented imperative style of programming. All three of these are OO languages that transpile, to use the very specific word, to JavaScript. And Coffeescript is particularly the one that is popular in the community. It actually, initially when it came out, it became very popular and people loved it. And what's happened over the last couple of years is that its popularity has actually gone down because people are like, you know what, I'd just rather write JavaScript. Because it's just, once I learn JavaScript and I start using more of the functional side of it, it actually becomes much easier. Okay? And I would say that, I'm not gonna say that you shouldn't look at these languages, right? TypeScript, CoffeeScript, or Dart. But what I'd say is that for a lot of people, it actually makes sense. If everybody in your shop is a Java developer, and you can't convince anybody to go functional and use ClojureScript or just write, functional JavaScript, and everybody is a, rock star, object-oriented Java developer, then it actually makes sense to use something like TypeScript. Because TypeScript gives you all the stuff that you're used to as a Java developer. It gives you classes. It gives you interfaces. It gives you all those things that you're used to in the Java world. You write TypeScript, and it spits out JavaScript that runs in the VM. So if you really want to stick to the object-oriented imperative world, which is fine, right? If you have great Java developers and they understand, object-oriented programming really well, there's nothing wrong with that, right? At the end of the day, it's about building a business solution, not about using cool new technology, right? But out of these three, TypeScript is my recommendation. Because if you're going to go down that road, don't go halfway down the road, right? You never want to stand in the middle of the road, especially here in Bangalore in the middle of rush hour. You might die, right? But what you want to do is, if you're going to go halfway, don't bother. Go all the way and use something like TypeScript, which gives you a full object-oriented stack to work with, right? I'm not necessarily saying you should use it, but if you want to, that's where you should probably go. All right. So when we talk about ClojureScript, what we're doing is we're writing in a functional language, and ClojureScript gives you all of the high-level functional programming constructs that you are used to in a functional language, right? But it compiles down to JavaScript, which is very handy, so you can then run it in a browser. So in terms of ClojureScript, ClojureScript is mainly for the web browser, okay? So Clojure is for the JVM. It runs on this, let's just say it runs on the server, right? That's not completely true because you can write Clojure and access Java Swing and build a Java Swing client using Clojure. And actually there are libraries that help you do that, and a lot of people actually love it because it reduces a lot of the noise you have in Java Swing if you've ever built a swing application, you understand what I mean by there's a lot of noise. You end up writing a lot of code. But my point is that ClojureScript is a client-side language, and it emits JavaScript that is meant to run in the web browser. So that means that you can use ClojureScript that gets deployed to the web browser, but you can still keep whatever you have on the server. You don't necessarily need to run ClojureScript. Theoretically, it can run on the server using Node, or it can output JavaScript that is NodeJS compliant, so that you can literally write JavaScript or write ClojureScript that runs directly on the client in the web browser, or runs on the server on Node.js, because Node.js is a JavaScript server-side execution environment. But, for example, we use Rails, but we still have a little bit of ClojureScript in our code base, because that just gets deployed to the web browser. That's okay. We still keep our Rails infrastructure with our RESTful API points, and we're fine, right? And if you're using JVM, you can use Play, or you can use server-side Clojure, or you can use Spring Web, or whatever, right? ClojureScript doesn't necessarily discriminate between those different server-side environments, because again, ClojureScript is meant to be a client-side, i.e. run in the web browser. So you can still keep all the server stuff you want, or you can build the server stuff, whichever way you want, right? And point here is, ClojureScript is only concerned with generating JavaScript. All right. So with that, let me do a quick demo to show you some code, some ClojureScript. What I'm specifically going to use here is what's called Lighttable IDE. This is a wonderful IDE that's come out of the community. It's been out for maybe 2 or 3 years now, and they've been slowly improving it. But this entire IDE is actually written in ClojureScript. So Lighttable does. You can use Lighttable IDE to write for a number of different programming languages. It supports JavaScript, it supports Python, it supports Clojure, and it supports ClojureScript, okay, among others. Right? So let's do a quick demo. So I have my Lighttable already running here. I thought I had it running, but then where did it go? Not good. All right, so I'm going to go open my workspace. And let's go into the Lighttable ClojureScript tutorial. Okay, and you can actually go to, if you just Google Lighttable ClojureScript tutorial, you'll find this entire code example on GitHub. It's done actually by somebody else. So let's go fire this up. This is going to be interesting. I didn't want that to die, actually, because I have, here it is. This is going to take a second to fire. So what I'm going to do is, this is ClojureScript running inside Lighttable, but we're going to connect to a web browser. So this will take a second. You probably can't read it at the bottom, but it's going in and retrieving some dependencies. But it's going to connect to connect to client, and let's connect to an external browser. And I already have some HTML in one of my demos. Oh, let me just go fix that. Work. Go refresh the page. All right, looks like we're connected. So now what I'm going to do is let me try to reorient this screen a little bit. It's going to be a little hard because this is such a small monitor. All right. Just go relayer this a little bit so we can see it side by side. All right, so what I'm going to do here is I'm just going to write something to the web browser, and I'm using ClojureScript. Again, the purpose of this demonstration is to actually show you and write some ClojureScript in front of you. Okay? So what I'm doing right here, let me scroll this up to the top. I know this podium is right in the way for people sitting over here. Let me scroll this to the top. All right, so one of the things you can do in ClojureScript is you can write directly to the DOM. Let me zoom in a little bit so you can see a little bit better. Okay? So one of the things you can do is you can use the ClojureScript write operation. I'm in the JavaScript namespace, write into the document object this string. So if I zoom out here, you see here's my web browser. I'm going to go in and change this and say hello. Right? I'm going to go run this, and you can see that it shows up in the web browser in real time. Right? So if you can't see that, you may need to move over on the other side. Right? So you can see that we're interfacing with the web browser directly in real time. So if you're familiar with Clojure, this is essentially like having a Clojure REPL open, or based in interactive environment for writing code into the target runtime. So, sorry. So one thing I can also do is I can invoke something directly in Lighttable, and you can see when I ran this, I said Clojure.string/blank. And so that Clojure.string is something that's in the ClojureScript library that is available to you. So here, where basically the blank question mark says, is that string blank? If I come in here and write something and then go execute it, what I'm doing is I'm hitting Alt-Enter. And what this is doing, this is converting this code into JavaScript, sending it to the browser. The browser runs that code, and then whatever happens from running that code in the browser gets sent back into Lighttable. And you'll see when I hit Control-Enter right here, you'll see that that now turns to false, because obviously I no longer have a false string, and we'll make that correct again, right? And I just have this alias here, and again, this is Clojure syntax. You can see I'm aliasing Clojure.string to string, so everywhere I'm at, I don't need to type Clojure.string. I've just aliased it as string, okay? So we can do other things in here as well. I'm going to make this full screen. Hang on just a second. Actually, we're not going to manipulate anything in the browser for a few minutes, so let's do this. So here I said define a string, here's the string, and then let's go reverse it. Okay, so this is just going to, the str basically will concatenate all the arguments after it. And I have two arguments. One is just a string called the secret word is, and then I'm using string reverse, and if I go run this, you'll see that the secret word is ClojureScript. Okay, so you can see I'm writing some ClojureScript now. Let's do a couple other things here. I can also define variables, or not exactly called variables, but essentially a variable here. So I can define x to be 1. That is not good. Okay, there we go. Let's try it now. There's exceptions. Okay, so I've defined x as 1. Now I can come in here, and I can just hit, again, Command Enter, and it'll say that x is 1. If I come up here and change this, so let's say it changes to 100, and I hit this again. Okay, let's clear all the inline results. And I hit this again, you can see it still thinks it's 1 because I run this block of code. I redefine x as being 100, I go run this again, x is that. Okay? So let's do a couple of other things. Let's actually define a function here. We'll define a function of y, which all it does in this case is just returns 1. So you can see there's like function declaration. And now when I go run y, again, the way you run something in Clojure is by you put parentheses around the block, and the first thing in the first item in the parentheses is the function you're running, and then everything after that are the parameters for that function. Okay? So when I run just y, you can see that I get y. All right, I can define a Boolean like this. I can define strings. I'll skip over the regular expressions for now, but let's actually do a map here. Okay, so we're gonna run a map that basically maps that defines a new function right here, and what it does is it multiplies the number that's passed in by 2, and then it runs that function against this array. Right? So if we run this, what's going to happen? It's going to define the function, and then it's going to apply the function, i.e. execute the function, using the next thing in the list, which is an array. So what should we get when we run this? We get 2, 4, 6, 8, 10. Right? It's pretty straightforward. And again, I know a lot of you haven't used Clojure before. This is just standard Clojure, but we're running it as ClojureScript. Right? And this is another way to do the same thing. Of course, we can define an array. Now, what we're doing very specifically here that's different is that we're doing a literal definition of an array using the array keyword here, right? So we can go define it like this. That gives me a JavaScript specific array. Same thing here. All right, but let's do something a little bit more interesting. Let's actually go, right, and because we're here, so we've done a little bit of a kind of very quick introduction to Clojure so far. We haven't really done much with JavaScript. And ClojureScript specifically. So one of the things that you do in ClojureScript to access the underlying stuff in JavaScript is you have a namespace called JS. Let me move the mouse out of the way. We have a namespace called JS, and that JS is essentially the root JavaScript runtime. And what's something that exists in JavaScript? A date object, right? A date object is a built-in thing in JavaScript. So what I can do here is I can define a date using JS/date, right? And so you can see here's the representation of it. And then I can define another date like so, right? Whatever. But you can see here's our, what we're doing, well, I'll come back to this in just a second, but let's actually take this JS date, and what we did before in our web browser was we just said hello Bangalore, right? Let's do something a little bit more interesting now. All right, let's actually call the JavaScript date command, and let's actually print it out, write it back into the DOM, or into the web browser. So what we can do is, where's my date DOM? Here it is. I'm just going to take this, and I'm going to go back up here to where I originally wrote that hello Bangalore. Where did it go? Did I go past it? Here it is. Okay? And we'll just say hello Bangalore. Right? And what we want to do is we want to concatenate two strings together. So in this case, I'll use the str keyword in ClojureScript to do that. I'll say hello Bangalore. Current time is, and then finally I'll put in JS/date dot. So what the date dot does is basically it says it's kind of reverse. Again, we're writing in a list, which is a functional language. So the way that we implement is the parameters are the same. You have the function parameters or function parameters, but when you want to new something up, you go grab the namespace. And to new something up, you put the object with the dot, and that basically news one up. So when I go run this, you watch over here in the browser, this should print out the current time. And you can see right there it says the current time is. Let's go clean this up. And actually, how do you do a line break in JavaScript? We'll be lazy and do, yeah, we'll just do a BR. We'll just be lazy, right? So you can see I did hello Bangalore. It concatenated those three strings together for me. And then it created a new date object and just basically converted it to a string, obviously, because I did I attached it, concatenated to a string, right? So again, here's our string. Our str basically represents a ClojureScript string function, and its parameters are just a group of strings that it just will concatenate together for you. Okay? We've done some basic ClojureScript now. Let's get back to the slides. What time does the session run till? I forgot. What's that? Oh, I have 10 minutes. Okay. You sure?
20 minutes before.
Oh, 20. Thank you. Okay. All right. So we've explored the language a little bit, right? And again, these slide deck, all the slide decks actually will be available to you from the GIDS website after the show, so you don't have to jot this down. You'll have access to all the slides. You can just grab this. But the tutorial that I was working through was by one of the committers of ClojureScript called David Nolan, and he's got, you can see we only went maybe a 50th of the way through the tutorial. He has a complete tutorial on all the different things that you can do with ClojureScript, right? Let me see if there's actually an interesting one at the end. Let me see if I can find it. I'm not going to go too much into this right now. Right? We'll come back to this in a little while if we have some time. All right. So again, what we did was we were using lighttable. You don't have to use lighttable. You can actually just use the command line, and from the command line you can get a REPL directly into a running web browser or into the Rhino JavaScript engine in the JVM. Okay. But in this case, we wanted to show it interactively in a nice way. Let's talk about the architecture for a few minutes of ClojureScript. So what ClojureScript does is we start from the ClojureScript source. What we have is we have the ClojureScript source, and of course this is not going to work properly. Sorry about that. That's the wrong button on my remote. Okay, so we have the ClojureScript source, right? That's what we were coding. And what happens is that ClojureScript source goes into the CLS JavaScript compiler, it converts it to JavaScript, and then from there it gets optimized by the Google Clojure compiler which produces optimized JavaScript, and that is what is actually run in the browser. So there are several stages that are actually happening here. If we drop to the command line really quickly, we should be able to see this. Actually, we may not even need to drop to the command line. All right, so let's go. This is another example, but I'll just show you the output really quickly. Right, so here's a ClojureScript, and somewhere in here, right? So this is what the actual generated JavaScript looks like. So again, remember I said we're using Google Clojure here. That's what all this stuff at the top is. Let me zoom in a little bit so you can see it better. Right? So you can see here at the top we have google.provides CLJS core. In this specific example, it pulled in array, object, string buffer, and a bunch of other things. Again, this is all Google Clojure. It has nothing to do with ClojureScript, except for the fact that ClojureScript uses Google Clojure to provide all the utilities that are missing in basic JavaScript. Okay? So then if we scroll down here, you'll see there's a lot of code in here. But this is all the compiled code or generated code that ClojureScript produced for our example. There's a ton of stuff in here. I'm not even going to try to attempt to explain any of this. I rarely look at the generated code, to be honest with you. It's just not necessary. Okay? So this is what the CLJS compilation process looks like. So the ClojureScript code becomes JavaScript. The JavaScript is optimized by Google Clojure compiler and also provides a lot of low-level utilities that we need to be able to have a comprehensive programming environment. Right? So for example, the Google array object and the Google Clojure object, string buffer. Google Clojure is actually a great library. You don't have to use it with ClojureScript. You can just use Google Clojure with standard JavaScript if you want. Okay? And then that final JavaScript is what actually gets compiled and run by the browser. Right? Let me talk a little bit about setting up ClojureScript, because this can be a little bit daunting if you're new to it. What you do is there's a build tool called Lean, or Line. I can't remember how they pronounce it, but it's a standard Clojure build tool, right? It's like the Maven or the Gradle of the Clojure world. What you do is you install Line, and then you do, once you have that installed, you say line new MIES, which is a specific name for a template, in this case, hello world. It creates a minimal ClojureScript project. I'm going to show you what it produced in just a second. And then once you have that, what you have to do is you have to take your ClojureScript code and you have to invoke something so it takes your ClojureScript and converts it to JavaScript, right? So that's what the next bullet point does. Lean CLJS build auto hello world. What the auto is doing here is it's saying whenever a ClojureScript file changes, go and recompile it and output me some new JavaScript, right? It does a automatic compilation during the development phase. And so let's have a quick look at that really quickly. So in my project.cls, what gets output, I'm just going to jump to the editor here. So here's my hello world. Right? And let's close that. And let's first look at the project.cls for this. There's actually not a lot here, because this is a very minimal Clojure project specifically for ClojureScript. Right? So we pulled in a couple of dependencies. We obviously still need to have Clojure because we're still writing in a Clojure environment. Here's our ClojureScript dependency. We have a specific plugin, CLJS build. Again, that's to take your ClojureScript code and build it into JavaScript. This is where the source path is, and this stuff down here basically says this is where you should grab the source from, and this is where you should output the generated JavaScript to. And in this case, it's being sent to hello-world.js. Okay? If we have a look at the rest of this project, we go to the index.html, you'll see that we are going in here and we are pulling in right here. Here's our hello-world.js. We do need to include some of the Google Clojure basic libraries. That's what the first line does. We include the hello-world.js, and then we invoke the context or the namespace that was created by the Google Clojure library of our generated project. Okay? So that's the index.html that we're running here. So if I come in here and reload that, you'll see that that's what we're running. Right? That's what our project file looks like. And we've talked about this already, but I'll review it a little bit more. Right, so if we go into our application, I'm going to switch out of our light table tutorial for a second, and I'm going to open helloworld.js, helloworld.cljs, and I need to attach this to my running web browser. Where's my web browser going? There's my web browser. And what I'm going to do in light table is I'm going to hit Command Enter to go run something. For those of you sitting over here, you can see at the bottom it's saying it's connecting. Now it's going to go retrieve dependencies. That's right. It's going to go download the world, I guess. Hopefully this won't take too long. Okay, there it goes. So now we're connected to an underlying runtime. See that ran? Now what I can do, if you watch here closely, one of the things that we did previously is we just went directly manipulated the DOM by writing something to it, right? But you can also do write to the console. So here we have, right here, you saw I did something similar to this earlier where I wrote directly into the DOM, but you can also write to the JavaScript console. So let's say we just want to log out something. So the first thing I do is I define a new function called foo. It takes two parameters, A and B, and it adds the two parameters together. So if I just go do foo 5 and 7, I should get 12, right? 12, okay. So again, this is running in the browser. It's sending the code to the browser, it's coming back and giving me the results. But I can also take that function, and by using .js console, write it to the console. You can see it just popped open in the console. Let me change this up a little bit. So 5 and 7, and you'll see it'll say hello world 12 in just a second when I invoke this, right? So you get the idea what's happening. I know that's a little small, but you get the idea, right? And of course, we can go write more stuff to the DOM here. So we can say, I'm just going to grab this real quickly. We can say write to, in the JavaScript namespace, in the document object, do a write function with this string. Actually, let me just get rid of this string and let's just say, is it lunchtime yet? Or something. Right? And you'll see that is it lunchtime yet pops into the document. Right? So there are lots of other things we can do. Say that we wanted to write something out a bunch of times. Let me go clear this out. Okay, actually, let me put a comment in. One way that you can do a comment against a specific S expression, right? So in Clojure, each one of these statements is called an S expression. And the way you can comment out a specific S expression is by putting a # underscore in front of it. So let me save that. Right? So you can see that now all we have is this. Let's actually make this completely blank so we have a clean slate. Save. Reload the page. Okay? And if we go back here really quickly, you'll see that I've had, the whole time that we've been talking, I've actually had CLJS build running in the background. So let me clear this out, and let me make a quick change here. I'll just insert a blank line for now. Save it, and you'll see that this just popped. It basically detected the change, took the CLJS file, compiled it to JavaScript, ran it through Google Clojure, and made it available on the file system, which I can then go load into my web browser. Okay? So let's do something a little bit more interesting here. So let's say do number of times, n is equal to 5, or n is the it, if you will, or the parameter that we're going to do 5 times, and we'll just say log that out 5 times into the JS console log. Right? So if I'll enter here, you can see n is 1, 2, 3, 4, 5, but we can also take this and instead of just writing into the log, I'll get rid of the log statement here. Okay? And I'll say, let's write, is it lunchtime 5 times into the document, right? And you can see that did that, and that didn't work so well, so let's see if this works. Nope, that didn't work either. And we'll just be lazy and do that there. Okay? Right? But you get the idea. I'm doing interactive development directly from my editor into a running web browser. Okay? And of course, the other things that we did before, where we used, is the Clojure string operations, is this string blank, etc. We can do all those things as well if we want. All right. So let's move forward a bit. Again, the JS that I was using in the code example refers to the JavaScript global namespace. That's why I was able to do JS document or JS /state. It basically reaches into the JavaScript environment and goes and finds that thing, right? And remember, we're not running on the VM, so we can't do java util.date dot, right? Let's see what happens if we try to do that. So this is the key thing that we want to remember here, is that we can't just reach into the Java core libraries and start using them, because we're doing ClojureScript. We're not doing Clojure, we're doing ClojureScript. So if I come in here and I put java util.date dot in here, right, let's uncomment this. And let's bring our web browser back up. Let me layer all my stuff back on top. All right. So now if I go run this, nothing happens except I get an error. It says Java is not defined. What are you talking about? There's no Java here, right? So you can't do that. Again, you have to remember that you're working in a web browser. You have the JavaScript runtime, not a JVM runtime. Okay? So let's change that back. Slides. So I've already done the interactive development demo, give you an idea of how this is all put up. But again, the idea here is to always remember when in ClojureScript we're hitting the JVM, right? This lean CLJS build takes our JavaScript, our ClojureScript, turns it to JavaScript. If we flip over to, and this is totally frozen now. Oh, that's cute. This is not good. All right, I think we're done. No, I'm just kidding. I'm just going to try to see if a sleep will. No? Oh, this is weird. Okay. I really don't want to do a hard reset on this. Looks like that's what I'm going to need to do. So I've brought this MacBook one time too many. All right, well.
Try it in F4.
What's that?
F4.
Or nope. Nothing is working. Great. That's just amazing. All right. See if I do a forced sleep. I guess it's time to get a new Mac, huh? Yeah, the keyboard is completely dead. All right. We only have 5 minutes left anyway. There are a couple of different ways that you could write this. In this demonstration, I've been using the Lighttable IDE. It's really a nice environment for working in ClojureScript, but you don't have to use Lighttable to do your stuff. Okay? You can use a number of different environments. You can just write in a plain text editor if you want. Oh, that was fast. And of course, we're going to lose our link here, but let's see if Keynote came back up. There we go. Recent. ClojureScript. All right, sorry about that. It has not happened before, believe it or not. All right. So in terms of the setup, again, well, one of the things I did that I glossed over was in that HTML page, I had a reference back to the running Lighttable instance, okay? And that is essentially how things were being sent back and forth between the web browser and my Lighttable IDE. Again, same thing you can do with Clojure, right? And as I was typing, I hit Command-Enter. It would run that command. If a result was produced, it would send it back to Lighttable and show me that result, right? So a couple of closing thoughts. Now, if you're using ClojureScript, sometimes you may want to use another JavaScript library. Let's say you want to use jQuery so that you can go and get direct access to DOM elements. There are lots of useful things in jQuery. Well, you can actually use jQuery with ClojureScript. You can use pretty much any JavaScript library with ClojureScript, and you don't nominally need to change much in terms of gluing that together. So it's pretty easy to use the standard JavaScript library with ClojureScript, right? You can use Backbone, for example, in ClojureScript if you want. But there are a couple of exciting projects. So again, you can use jQuery. Somebody has a really nice demo of using Raphael, which is a JavaScript graphics library in ClojureScript. Right? But one thing I really want to point out to you, something that's on the horizon that's been developed for a little while, is something called OM. Okay, and it's by the guy as one of the committers on the ClojureScript project. But it is essentially ClojureScript that has been melded together with the Facebook React library, right? And one of the reasons why Facebook React right now, and here's a URL for Facebook React here at the bottom. One of the reasons why Facebook React has been gaining so much attention recently is that it is extremely fast. What it is it does a couple of different things. I don't want it. Talk on React can take all afternoon, right? If we got deep into it, but Facebook React is something that you should go have a look at because it changes the way we approach building applications, and it has a lot of things underneath the hood that allow you to make super fast single-page web applications. One of the things, for example, that React has in it is that it has what's called a virtual DOM. So when you use the React component and you want to go change something in the DOM, what it does is actually changes it in the virtual or shadow DOM, and then it goes and applies it. Instead of doing a manipulation in situ in the DOM, it goes and replaces an entire DOM node, and that's one of the reasons it's very fast. But anyway, what Swan or David has done, right? There's a link to the GitHub repo for OM at the bottom. What OM is basically it's ClojureScript melded together with the Facebook React library, and some of the demos he's done on it are really interesting. So there's the To-Do MVC website, todomvc.com, where basically people, using Backbone or Angular or whatever, they have implemented the same to-do list application in all these different frameworks. So what he did is he ran a test of adding 100,000 to-do list items, checking them all off, and deleting them, right? Using Backbone. So he ran the benchmark against Backbone, that specific test. Again, it's a to-do list application written in Backbone and a bunch of other libraries. Specifically, he ran this benchmark, add 100,000 to-dos, check them all off, and then delete them all, right? Using what you would normally do as a user, you type it in, click, and then click delete, etc. And that took on the order of, I think, like 80 seconds against Backbone. Okay, and against Angular, I think the benchmark was like 45 or 50 seconds. So, and then he wrote the same application, the to-do list application, using ClojureScript and OM. He ran the same benchmark against, again, it's just a web application, right? It's just something that JavaScript that runs in the browser. Does anyone want to guess how long it took to do the same thing in OM specifically? Again, Backbone took 80 seconds, Angular about 50. How long did running the same benchmark speed take for OM? Take any guess. 10 seconds. That's not a bad guess. Keep going lower. Keep going lower. It took on the order of 500 milliseconds to run the same test. So when we talk about performance, especially if you're building a complex single-page application, you should definitely look at React. If you think you're ready to jump into the JavaScript or ClojureScript side of things, you should look at OM. Again, it's a very nice integration, and he has some nice tutorials on there. And with that, we're at the end. I think we have some time for some questions. So take questions for a few minutes on ClojureScript or OM or whatever. Any questions? Hopefully this all made sense to you. Yeah, go ahead. Yeah.
What's the implication of not doing that?
Well, it was well, all that happens underneath the hood, right? So it takes your ClojureScript, it has to convert it to JavaScript for it to be able to run in the web browser. So, there's... I understand. So your comment is how does it convert a Clojure type into a JavaScript type and round trip, right?
How does it, but is that something you already have to do when you're writing
Yeah, you don't have to do that. The ClojureScript does all the kind of type translation. At the end of the day, the type actually doesn't exist in ClojureScript at all. It only exists in the web browser. So when we did that JS state, it never existed in our ClojureScript code. Like, man, it never materialized is the right word. It only materialized in the browser.
So when would you need to convert it to a JavaScript or JavaScript specifically? What is the new one?
Yeah, so there's some helpers in ClojureScript that allow you to write ClojureScript that interface directly with JavaScript types, if you will. Right? More questions? Yes, ma'am.
You were telling about using it from a command line and not generally use an ID.
Right.
In a case like that, you will have commands to invoke the Google compiler. I mean,
No, all that still happens automatically. You don't worry about that. All you do is you say lean CLJS build, and then I'm trying to remember the syntax because I don't actually use the interactive REPL that much because I just like using Lighttable. It's a really nice IDE or environment for doing it. But I think what you do is something like lean. Maybe you can just do a lean REPL here. There's a very specific command you give it to run the ClojureScript level, but let's see what happens here. All right. Now see, this is just a Clojure REPL into the environment, not the ClojureScript one. I don't remember what the exact command is, but you could, like, we could get a standard REPL not just into the Clojure, but into ClojureScript from the command line. I don't remember exactly how you run it. Right. So this is just going to give us a standard Clojure REPL. But if you Google it, you'll find it really easy. I just don't know what it is. So I would just use Lighttable. I prefer using that.
The other question was now ClojureScript is compared to JavaScript, which is again Clojure compiler. Is there any overhead of the fact that you're converting one language to another?
Okay, so the comment is you're going from ClojureScript to JavaScript. What's the overhead, right? So the overhead we care about is the actual overhead at runtime. How fast does it actually run, and what additional stuff does it generate? So what I've read, I don't know too much in detail about this, but from what I've read, there is some additional overhead because we're using Google Clojure, which is this big library, right? That it's just a standard JavaScript library, but ClojureScript is based on Google Clojure. So you do get a significant amount of overhead, okay? But it's not a huge amount, but it is significant. I don't remember what the exact numbers are, but you do get a lot of the stuff. But again, one of the reasons why they use Google Clojure is that it only takes parts of Google Clojure that it needs. Remember when I showed you this, when I showed the source, the actual JavaScript source, it had, I think, 3 different Google Clojure libraries that it imported, but not the entire Google Clojure library. You'll get 3 different things. You'll have more code, obviously, because it's doing a translation. It's using Google Clojure libraries, so that's additional code, right? And then you also have your code itself. So you get overhead from the size, the download, the memory footprint, and also the execution is actually fairly fast. It's very close to just writing straight JavaScript. Okay.